Hey guys, I hope you're having a great weekend. We are starting Unit 13, which is going to be our last test, second to last unit, and it is over acids and bases. And to get started, we're going to just review acid and base naming today, and then go over what an acid and a base are. So an acid is a chemical that donates protons or hydrogen ions and slash it accepts electrons. You'll get a lot more about this tomorrow in the PowerPoint, but the key thing with an acid is the formulas usually begin with H, and usually like 100% of the time. A base is the opposite of an acid. A base is something that donates electrons, acids accept them. They accept protons, acids donate them, and then they release hydroxide ions in aqueous solutions. And so, because they release OH, bases have OH in their name or their formula. So the big thing I really want you to know right now, acids start with H, bases have an OH group in their formula. Now, we did learn how to name acids back in November. Doesn't mean you remember it, not totally expecting you to remember it, which is why we're going over it today. Acids, their formula begins with H. Some examples, HCl, hydrochloric acid, HNO3, nitric acid, H2SO4, sulfuric acid. And so how do we get those names? Why do some have hydro, some do not? So, reviewing. To write the name of an acid, you have to look at the formula. That seems like common sense, but a lot of people don't do that. If there is no oxygen in the formula, then you're going to add the prefix hydro to the beginning, add the suffix "ix", and then add the word acid. So you have to look at the formula. And if there's oxygen, if there's no oxygen, it gets a hydro. So some examples. None of these have oxygen looking at the formula. So HCl, there is no oxygen. I'm going to go ahead and write hydro. Now Cl, that is chlorine, so it becomes chloric instead of ene, and then acid. H2S, no oxygen, so it gets a hydro. And then S is sulfur. Now sulfur, actually you put the whole word and then you add IC on it. So hydrosulfuric acid. And then the last one, H3P. Again, no oxygen. So hydro, and that is phosphorus is a P, and it becomes phosphor. So don't write the us-ic acid. Hydrophosphoric acid. And here they are, nicer and prettier. So no oxygen, hydro, and then ic for the suffix, and everything gets acid. Now, if you were to do the opposite, let's say I gave you the name and I asked you to write the formula. If there is a hydro present, then you know there's no oxygen, and the formula is just H plus whatever the nonmetal is. So this is doing the opposite. So these two, hydronitric acid. Look at that. I know there's not an oxygen, so it is H and N. But we have to think about charges. Hydrogen's a 1 plus, nitrogen is a 3 minus. So that becomes H3N. Hydrobromic acid. No, there's a hydro, so there's no oxygen, it's just H and Br. Hydrogen's 1 plus, bromine is 1 minus, so that is HBr. Now, if there is oxygen in the formula, and we want to write the name. So if there is oxygen in that formula, there is no hydro. If you see an oxygen, there's no hydro, which means you're going to have to look at your formula and determine what polyatomic ion is in that formula. Now you have your polyatomic ion list. You need that. Just have that out on your, by your notes as we do this unit. So if the polyatomic ion in the formula ends in 8, which requires you to look at the formula and recognize the polyatomic ion, then it becomes ic acid. If the polyatomic ion in the formula ends in ite, then it becomes us acid. And neither one of these have hydro. There's no hydro when there's oxygen. And here's your list of polyatomic ions. Just to refresh, if you don't have them, you might want to, or you lost that paper, you might want to write these down for quick reference. Now, reminder, this is not all of the polyatomic ions that exist. There are a lot more. And then a lot of these polyatomics that end in 8, they also have an ite version, even if it's not listed. And then the ite version is always one less oxygen than the 8, but the same charge. So I might ask you about carbonite. You know carbonate, CO3, 2 negative. Carbonite, CO2, 2 negative. Let's look at some others. Phosphate. Phosphate is PO4, 3 negative. So guess what? Phosphite is PO3. It's supposed to be 3. 3 negative. That ite has one less oxygen than the 8, but the same charge. And some that are on this list have ites, even though we don't have them listed. So if we were to name these. Now, again, the polyatomic that ends in 8 becomes ic acid. The polyatomic that ends in ite becomes us acid, OUS. So H2CO3. Looking at that formula, CO3, that is carbonate. And so it will become carbonic acid. HClO3, I would look at that. That has oxygen. What is ClO3? That is chlorate. So it will become chloric acid. There's the name. NO2. Looking at my polyatomic, NO2 is nitrite. So it becomes nitrous acid. And then I just have all of that written a lot nicer. Well, not written, I have it typed nicer for you. So, to review, if there's not an oxygen, it becomes hydro whatever ic acid. If it has oxygen, figure out if the polyatomic ion is an 8, it becomes ic acid. If the polyatomic is an ite, it becomes us acid. Some ways to remember them. Remember the saying, you ate something icky. The 8s become ics. Sprite is delicious. The ites become us acid. So we're going to practice. These are mixed up. So number 1, ClO4. That has oxygen in it. So what is ClO4? Go look at your polyatomic ion list. That is perchlorate, which means it's an 8, so it becomes perchloric acid. Next Next one, H3N, no oxygen, so it gets a hydro. And then the next thing is an N, so nitric acid, hydronitric acid. Number 3, dichromic acid. There's not a hydro, so I know it's a polyatomic ion. And then dichromic, which means it was dichromate. And go look at your polyatomic ion list. And dichromate is Cr2O7, 2 negative. But it's an acid, so it has H in front. H has a charge of 1 plus, 2 negative, 1 plus, so that formula becomes H2Cr2O7. And then the last one, chlorous acid. When I look at that, Sprite is delicious, so chlorous means it is chlorite. Go to your polyatomic ion list, and I don't think chlorite is on there, but chlorate is on there, and chlorate is ClO3, 1 negative. So chlorite is ClO2, 1 negative. Because the ites have 1 less oxygen than the eights. And then it's an acid, so the formula starts with H plus, and hydrogen's a 1, and that formula becomes HClO2. And I'm going to highlight the names for you in case you can't read through my writing. Oh, I forgot I did that. Well, there we go. And then naming bases. Just about every base has a hydroxide group, which is OH1 negative, and remember that's a polyatomic ion, so those stay together in the formula. And so if we were to write these formulas, magnesium hydroxide, magnesium is 2 plus, hydroxide, OH, 1 negative. And because this 2 here, 1 here, OH has to be in parentheses, and you put the 2 outside of it. Lithium hydroxide. Lithium is a 1 plus, OH, 1 negative. Those charges cancel. It is LiOH. Manganese 3 hydroxide. Do you remember the parentheses tells us the charge? So manganese is Mn3 plus, hydroxide OH 1 negative. That formula becomes Mn parentheses OH 3. And that's naming bases. They're easy. Acids are definitely the tricky one. So acids start with H's, bases have OH. You're going to go take a quiz on Canvas now, and it's going to be worth 50 points of an other grade, and you can take it up to 3 times to get your full 50 points. Good luck.